Okay, for this physics problem, we're gonna try to find the full acceleration of a block on a ramp that has friction at a certain degree. Before I start, I just want to say, when I make these, it's partly for myself to understand it better, but it's also partly for it's also for you, but it's for me so I can come back later, come finals, and restudy these, because honestly, I have trouble with this sometimes, because sometimes my teacher, as well as he does, I feel like he forgets to get some of the very basics, which make the rest of it very hard. But I had my epiphany today with him after school and with a few of my friends, so I'd just like to share that with you and kind of practice it. So let's set this problem up. We have a ramp. And the ramp, we're going to say, is at a 46-degree angle. So just right away get in the habit of just labeling your variables, and you really don't even need to label angle, but I'm just going to for your sake. Angle equals 46 degrees. We're going to say the length of the ramp, so this length of the ramp, which we'll call x, is going to be 12 meters. We are also going to say that the time it takes to go down the ramp is actually, hold on one second. Scratch that. We're not even going to use time. We could use time, but in this case we're not going to need it. We're not going to have time. So first thing, let's write down some simple equations. Not simple, I guess, but let's write down some equations we're going to need to use this. To find acceleration, which is what we're trying to find, we're going to need force divided by mass. And in this case, that's what I didn't label. Our block is going to be, we'll call it 5 kilograms. So we'll go up here, we'll go mass equals 5 kilograms. Okay, so back to the equation. Acceleration equals force divided by mass. In this case, it's the net force, not just the force, because force is easy to find, but in this case it's not, because it's on a ramp. So it's force net, which is going to make that a little harder. First thing you're going to want to always do when you start these problems, sometimes you might not even need it, but I just recommend, you want to make a 90-degree angle to the ramp, and then you want to make one straight up and down. This will help you find the three components of this triangle are pretty crucial. This component right here is the weight, and weight equals mass times gravity. In this case, our mass is 5, and our constant of gravity is 9.8 meters per second, so we do 5 times 9.8, and we get our weight to be 49 newtons. Next thing we're going to want to find is our normal force. You can call this WY, whatever you want, but for the sake of the equation, normal is going to make more sense to you. Normal, which is what's resisting the weight of the block, we're going to have to use some trig proofs to find it. Using geometry, what we know from geometry, this angle is congruent to that angle, since we've made a 90-degree angle here. So we know this is 46 degrees. Okay? Using that, and since we know this is 49, we can find our adjacent angle. So adjacent over hypotenuse is cosine, so ka toa. So cosine 46 equals adjacent over hypotenuse. To undo that, we multiply by adjacent, or excuse me, multiply hypotenuse, which we know to be 49. Okay, so that simplified out is 49 cosine 46. And you just have to do that on your calculator. Oh, sorry, I'm getting a call. Just ignore that. And then our calculator is 49 cosine 46 is 34. Okay, so our normal force is 34 newtons. It's close enough, we'll call it 34. 34 newtons. Okay, now we need to find the force going down this way, which is Wx. Again, it doesn't matter what you call it, usually it's Wx though. So, using our proofs, or excuse me, trigonometry, we're going to use our angle and our sides that we know. So opposite over hypotenuse is so sine, so katoa. So sine 46 equals opposite over hypotenuse. Again, we multiply by the hypotenuse, and we get 49 sine 46. And that in our calculator is 35.2. So we'll go back up here, we'll call Wx 35.2 newtons. I should make this one a large n. Okay, now we have, we can also put our weight here. Now we have the components of this triangle right here. Excuse me, I need a drink. Now that we have our components, we're going to go back up to our acceleration equation. So let's rewrite that down here. Acceleration equals F net divided by mass. Okay, what's F net? F net is the net force wow, voice is still sore from yelling at the game last night. It's the net force, so the combined force acting on this system. This is an important part to recognize. The Wx is the force going down. That's the force the block is going down the ramp with, okay? So we have F net, we'll simplify this out again, equals Wx. Now what's the other force? Well, the force, oh, wow, I can't believe I forgot this already. But our friction coefficient, well, let me back up. This is mu. That's the sign for mu. That's used for your friction coefficient. We'll call our friction coefficient 0.12. I can't believe I forgot that. Let me briefly explain what our friction coefficient is. Friction coefficient 0.12 means 12% of the mass of the force going down is going to be used to resist it. So it's just 12% is fighting back. I can't believe I forgot that. So when you're finding friction, we have the force going down the ramp. Now the force resisting it is friction. And friction, we'll write this up here in our equations, friction equals mu times our normal force. Okay, now we know in most of these problems you're gonna get mu. So, and if you don't, I'll probably do another one to show you how to get it. It's just kind of same problem, different way. But since friction is acting against it, it's gonna be a negative. We're gonna subtract it and we're gonna divide by mass. Okay, let's go down here. We know Wx we know Wx to be 35.2. Okay, we got that. We don't know friction. Well, we can find that out. Friction simply equals mu times normal. Now that makes sense because the normal force is the force pushing up against the block, and it's the same as the block pushing down. That's why it doesn't sink into the ground or float off the ground. It's the same. So like if you push on a table, the normal force is what's pushing your hand up, and it's the exact same as the force your hand is pushing down. So we multiply 0.2 times, it's just 0.12, excuse me, times our normal force, which is right here, times 34. And we get 4.08. So we read this, 35.2 minus 4.08 all over our mass of 5. And that calculated out is going to be 6.2 hold on one second. 6.22 meters per second squared. And now we've solved our problem. We found the acceleration of the block going down the ramp. Now let me take this through one more time, just kind of step by step so you can understand this. First thing we did is we write down all our variables. They really help to make this, to simplify the process. Next, what we did is we write down all our simple equations, which can be rearranged to okay, sorry, I was interrupted there for a second. Let's see where we left off. We've got our equations. Next, what we did was we found our components of this little triangle we drew in to find our Wx, our natural force, and our weight. And we listed those all here so we can use them. Next, we referred back to our equation of acceleration, which is we're ultimately trying to find. Then we solved for F net using Wx minus F divided by m. Wx found friction. That's what the little f is. Maybe I should label that. Which is our mu, which is friction coefficient, times our natural force. And plug that in up there, subtracted there. Boom. Acceleration equals 6.22 meters per second. Hope this was simple enough to follow, and hope you understand it. Let me know if you have any questions. Thanks, bye.